The deep protection. I'm pretty sure this is a no op. What is the deep protection mechanism? Deep protection. But it doesn't reduce ethers, so that's why this thing works. Or So what does acetone? Yeah, this is the same as this. This is acetone. Then this is we gotta remember the names of this shit. This is gonna be oh, it's benzaldehyde. I don't know the mechanism though. Yeah, so I was right about that. Yeah. And then yeah, okay, that's all easy. And it's the same for the other one. Let's just make sure it's benzaldehyde. Okay, it's benzaldehyde. Good. That's not so bad. Okay, so there's a special name for these. It's like an ochem or something, right? I think an ochem. No, it's a uh yeah, it's an ochem or aldoxeme or ketoxeme. All right, so we have pentan 3-one plus, and this would be called hydroxylamine. Yeah, hydroxylamine. So NH2OH is hydroxylamine. And you could think of hydroxylamine as RNH2. So what that means is it's uncharged. So it's going to go and form an imine. So it's going to form an ochem imine. Yeah, I got it. So let's do the mechanism. So the first thing that happens is nucleophilic attack onto the ketone. So let's just do this. So this is like this. H2R. Okay, so now I have. Oh, wait, this is an O. This is an O. This is an O. Okay. Now what happens is acid. Presumably there's acid in here. Or something. Presumably there's acid in here. 'Cause I think it has to get protonated. Then the lone pair dumps into a pi, kicks off water. And that forms the imine. So this looks like this. NHR plus, and then water comes and takes off this proton. And we have our imine. And our imine is actually equivalent to OH. Yeah, I got it. That one's pretty easy. Now this one is where you get the enamine formation. But let's shit. Minimize information nucleophilic addition, the amine coupling. To transfer neutral covalent, which combined convert into a water good leaving group. Loss of water through the use of a lone pair into the from an aminium. At this point, the mechanism differs. If the amine is primary, the aminium is deprotonated to yield an imine. If the amine is secondary, an alpha hydrogen is removed and an E2 like process yield an enamine. So it's literally just enamine. For imine. Okay, so we got the imine. Now let's do the enamine. We're doing this one, which is, there's a name for this, but it's like, this isn't a acetyl group. What do you call this? The Wi-Fi is so fucking bad. I can't. Pro is too slow. It's actually a terrible name. I really prefer the 1-phenyl. Yeah, 1-phenyl F unknown. 1-phenyl ethanone. That's a way better name. Acetophenone, bro. That's one of those. Also, methylphenyl ketone is also good. But acetophenone's a shit name. Alright, because it doesn't mean anything. But so where are we at here? Alright. So this plus CH3, this is called dimethylamine. Dimethylamine. And so here's what happens. We're gonna get the iminium ion. So let's just draw the iminium ion because we already know what that mechanism is. So you have the phenyl group. You have this NR plus, and then you have an H here. You have 3 H's here. And what happens is that water can come and take one of these guys, and then we get phenyl, NR. And then, so this would be, how do you name that? I don't know how you might do it, but it's NN dimethyl 1-phenethylamine. Okay, wait, hold on. 1-phenyl. Oh wait, no, it's N and dimethyl. One phenyl ethene 1-amine. What a name. NN dimethyl 1-phenyl ethene 1-amine. Alright, whatever. Okay, that's chill as fuck, dude. Okay, so that was 33. Okay, just basic imine and enamine mechanism review. Don't forget weird names like the, what is it called, the if you have an aldehyde group, carbaldehyde. Yeah, that's fine. The next one is 34. Predict the products and propose mechanisms for the following reactions. In imine, what happens to an imine in acid? And how do you even name these imines? We never even learned this. How do you name this? N-methylbutane 2. Oh, okay, cool. So this is N-methyl. I always find the N's really weird, but you know, it's like, what if there's two N's in it? Who cares? N-methyl butane 2-imine. All right, that's actually easy. I like that. N-methyl 2 or N-methyl butane 2-imine. Okay, chill. Chill. So what happens in HCl and water? I would assume that the lone pair on the nitrogen picks up an H. And then we get iminium ion. And then nucleophilic attack by chloride. Okay, let me do the next one. And then we'll check if I'm right. I don't know. I'm a little unsure about these. Okay, so standard, if you just have an alkene, an acid, the pi bond attacks the proton, right? And then carbocation forms on the more substituted. And then we get addition at the more substituted. So then you get Cl for something like butene. But here,
Let's just keep going.
so this would be NN dimethyl cyclohexonene, or one ene, one amine. Let's see, what's the name of this? I love names, dude. Okay, let's do this thing. So you assume that the logical thing happens where the proton is taken and is put on the least substituted. Why? Actually, you may get vicinal because if you think about it, this nitrogen is electron withdrawing. So actually, the carbocation is probably less stabilized there. I would assume. I would assume the carbocation to be here. Because N electron withdrawing group, the H adds to the less to the 2 carbon. This is my guess.
Dude, you know what's insane? You know what's crazy? You know absolutely baffling.
Or no, sorry. So it adds to the 1 carb. The H adds to the 1 carbon, but then the Cl is going to add to
I
the.
would say it's like right next door. But in the neighborhood, which neighbors? Then one of the people has a rainbow, another one has a Porsche 3RS, and one brother.
Okay, I'm not too sure about these mechanisms. Alright, so here's the enamine. Each mechanism. Oh, jeez. Wait. Oh, right. Oh, okay. Hold on. Let me think about this. Each mechanism is an example of an amine or enamine hydrolysis. The entire mechanism for each is the same with the exception of the first step. In problem A, the first step is protonation of the amine nitrogen to give an iminium. Yeah, that's what I thought. In problem B, the first step is protonation of the beta carbon. See, now that's where they lost me. The remaining steps, which are identical for both nuclear. What do we end? We end with a ketone, dude? Oh, okay. I gotta practice this one. I don't know this mechanism at all. Why doesn't the chlorine attack? That's what I don't understand. Oh, wait, no, NH2. NH2. Wait, no. No, just NH. Okay, so this is one of the best ones because it's just like totally. Oh, hey. We'll see. I'm doing the problems right now.
All right. I do have a question if you don't mind.
Yeah, go ahead.
Yeah.
Yeah.
So I was working on one of the chapter 14 book problems.
Okay. Yeah, I haven't done too much Diels-Alder. I'm gonna get there, but yeah, I'll look at it for sure.
Oh, shoot. Where is it? It's in here, I promise you.
Yeah, take your time.
All right. So,
Yeah.
you know how we need, like, assist
Yeah.
steroids? So, we got so many of them here. So, we got a pair here, a pair here,
Oh, wow.
and a pair here. I'm assuming because of sterics, this is what I did before thinking. I'm assuming it would bond here or react here. According to Vaughn, it's not going to be here or here because then we'd have a bridge, and bridges aren't the most stable.
Okay.
So it's like a huge what the heck do
This
you
is a
do?
1433.
Yeah, there is a solution. However, it only works for the cis formation of this part over here. And I am not sure.
You know about the
We can
like
rotate
student manual?
Student manual?
Yeah, like if you go to the OpenStax website, there is like a link to.
Oh yeah, the solution
Yeah,
key.
the solution key.
Yeah.
So this is the problem.
Yeah, that's the problem, but look over here. This is trans.
Yeah, but it's not really because it's a sigma bond, so it can swivel.
Okay.
So like
Yeah, no, that does work.
the only thing that constrains the S cis
Sterics.
is rings, because otherwise
That's
you can
true.
spin them.
All right.
So that's how you can get this shape.
Okay.
Otherwise,
got
you wouldn't be
it.
able to make that shape. Like for the rings, you can't
Oh,
swivel them
rotate
around.
the S is called. I
Yeah.
am so fucking serious.
No. I mean, I think it's like so easy to forget
Yeah.
that sigma bonds rotate.
Yeah. Man, I hope she doesn't give us anything crazy.
I know.
man.
Nothing on the Lumo Homo. I think she said that
Yeah.
she's not.
Yeah, molecular orbital theory is like out the window with this one.
By the way, did you try my app?
I
posted this.
looked at it. I don't like.
You know how to use it?
No.
Okay, so here, I type in propene, for example.
Oh shit.
And then I do HBr, Markovnikov HBr addition.
Oh
then
my
I can type
God.
in MG, Grignard reagent. Then I can type in, what's a good, like ethyl, or let's say acetone. That's a good ketone.
Nice.
And then you
dude,
can, like-
holy shit.
Yeah, and
That's
then you can
really
then you can
impressive.
oxidize it. Let's see, what's a good oxidize? Jones?
Jones.
Yeah, or like CR. Actually, Jones should oxidize this to a carboxylic acid, I think, but it might be steric. But see, how do we get an aldehyde from a tertiary alcohol?
An aldehyde from a
Oh, we can't.
tertiary
It's a tertiary alcohol. That's why it
Yeah,
doesn't
no.
work. Okay.
doesn't react.
So if we did, anyways, that's how you use it. Yeah.
That's
you
so
can
cool.
So you got most of the rules. I don't think Wittig works. Yeah.
On that, yeah, it's a really complicated reaction. But dude, that's really impressive.
Yeah. So
Holy shit.
I think for the final, it should help people. I
Yeah.
think I might just make a little video about how to use it.
That'd be really cool too. Also, from 4:30 to 6, Vaughn is going to be in the tutoring center.
Oh, okay,
So
cool.
I'm going to head over
Nice.
there.
Yeah.
Probably our whole class is going to be there.
Oh, okay. Yeah.
Yeah. Do you mind if I stay here with you, or do you just want to do your own thing?
Yeah. Could I just do my? Is
Yeah,
that okay?
yeah, yeah.
Thanks. I'm actually streaming right now.
My bad.
No, you're good. You're good. Usually, like Isaiah and Krish are in the chat. Actually,
Oh, word.
let's see if they.
All right. Really appreciate.
Yeah, no
I
problem.
completely forgot that it can rotate.
Yeah. That's a lot of the ring closure stuff too. It's easy to forget, but if you spin them around, then it makes sense.
Yeah, because there's this one problem where we could rotate it, and it's like, oh yeah, it's not going to like be as reactive because like sterics here. and
Yeah,
everything
yeah.
Like that, but it's still possible. Anyway, thank you so much.
No problem. Yeah. Okay. Predict the Okay, so this is the one. Okay, so I don't know this one. So, how do we form? Okay, so the first step was a record. The nitrogen is protonated. To an iminium ion. Now, because there's like now that carbocation is even more electrophilic, so water is able to come in and attack. Okay. So now we have N, methyl, H, and then a water, H2O plus, and then presumably you can deprotonate this just with that, and then you can NH methyl. Okay, but then what happens after that? Okay, I don't know this mechanism. I really don't know this. So, protonated to iminium, nucleophilic attack by water. Okay, so yeah, alright. So then acid again. Lone pair acid. So now you get another, it's not iminium, but it is a positively charged nitrogen. NH2 methyl, and then OH. And so now that this is a plus, yeah, the lone pair of okay, it comes in and dumps it. So then you get methylamine. Yeah, yeah, and methylamine, it's just like whatever. Okay, so finally we get a ketone, and then water just takes this proton from the oxonium, and then plus methylamine. All right. And yeah, you could say that this, but like, really? I feel like that's just, that's a bunch of baloney. That's a bunch of baloney. All right, so that's a good one. So that's how we. Right, so the main thing is if we have an imine in acid and water, we can form a ketone. So we can turn an imine into a ketone. Right, so that's a pretty good mechanism. I'm down with that. All right, so let me just write that down. So actually, we should write it down here. So 34, we can turn an imine into a carbonyl ketone with HCl and water. I don't think I have that mechanism. The mechanism is N-protonated makes imine C more electrophilic. Water attacks. Then deprotes. Then NHR takes another proton from HCl. Then lone pair from OH dumps to pi, kicks off NH2R. Then water takes new carbonyl proton. All right, so that's okay. So that's that. Now, enamine plus HCl and H2O. Okay, let's see this. Sorry, so let me see if I can predict now because I'm guessing it's going to be similar. Okay, so we have, let's see, what does the actual problem say? Yeah, so NN dimethyl, one cyclohex, one ene, one amine. That's probably how I'd name it. And it's gonna be okay. Wait, I gotta see the mechanism here because what is going on? Okay, fine. But anyways, let's just write down the mechanism because I don't have time for this shit. Okay, so we get cyclohexanone and this dimethylamine thing. Okay, all right. So, uh, first, imine, iminium ion form. Uh, the nitrogen lone pair goes into a pi, and the alkene pi attacks a acidic proton. Then, since the imine carbon electrophilic, water can attack, then deprotes, then Nr2 takes a proton and gets net charge, and oxygen can dump a pair into pi2. Then The following reaction begins with an acetyl and converts it into a different acetyl. Predict the products and propose a mechanism. The mechanism? Presumably it just turns into a carbonyl and then favors the other one. Okay, my guess is that this whole thing happens where it gets protonated, this lone pair, it kicks it off, then what happens? In the reverse case? Yeah, you go through a hemiacetal. Alright, let's just look at the answer. We don't have time for this, because I gotta get to the other chapter. So 35. Yeah, obviously, this is what forms. And then 2 methanols. Okay, that's fine. And the mechanism is that this goes, this dumps. Yeah, okay. And then here you have, at this point, you now have a hemiacetal. Because you have an, no, it's not hemiacetal. Yeah, okay. I mean, I feel like this is exactly the same as the other one. So let's just skip that. Actually, it's subtly different because there is no hemiacetal. And you just go straight to the attack. Okay. Alright, maybe I'll try. Okay, so we have this thing here. Now, I don't know why it prefers one over the other, but we have dimethoxy, 2-dimethoxy propane or something like that. Anyways, here's what happens. And we have HCl. So the very first thing is that one of these things gets protonated. And then this thing dumps into here and kicks it off. And so now we have this becomes a methanol. And now we have a, what is that called actually? Well, it's a plus, so it's not stable. But then the other comes in. This goes to okay. And now what? This one takes a proton, or? Yeah, this is fine. I'm okay with this step. It's now, yeah, so then this thing, it's already 2 hours left. Dude, I got this. Yeah, I don't know why I'm even stressing. I fucking got this. I'm goated at chemistry. Actually. I'm actually fucking sick at this stuff. Alright, so this is the second methanol. Okay, I got it. Alright. Is this one the same? Yeah, it's like the same exact thing. So the only distinction in mechanism here, there's no hemiacetal intermediate because the other alcohol attacks before water. Okay, that's it for that. Alright, 40. Ooh, thiols? Dude, we didn't learn anything about thiols. Aldehydes and ketones react with thiols to yield thioacetals. Oh, really, dude? Why is there so much on acetals? What is the point? Does anyone care? Acetals? Uh, 40. All right, let's do it. I mean, this is going to be easy, right? So this is, what do you call this? It's not going to be ethanol. It's going to be called ethanethiol. Okay. All right, so thioacetal formation. So we have cyclopentanone, plus ethanethiol, which is going to be SH. Okay, so in acetal formation, bro, there's actually so many mechanisms and I keep getting confused. In acetal formation, is the first step protonation of the carbonyl, or is it just nucleophilic attack? Okay, it's protonation of the carbonyl oxygen. Alright, so we have, is there acid? Okay, so there's acid. Okay, so this thing comes and takes this, then we have and then nucleophilic attack by the SH. Okay. I mean, she really wants us to know these fucking acetal problems, dude. It's like the exact same thing. Yeah, you protonate it, nucleophilic attack. Okay, then you take a proton. Now it's like kind of stable. But then this thing gets, yeah, and hemiacetal, hemithioacetal. Okay, so here we call this the hemithioacetal. All right, that makes sense. And then this thing gets protonated, right? So then this comes in to form a thional. I think it's called a thional. And once we have the thional, another molecule comes and attacks. And then we have the thioacetal. Alright, that's pretty easy. Oh no, you lied. Naming, okay. Ooh, okay, naming is actually good. Bromoacetone. Bromoacetone, dude. What the fuck is that? Okay, that's what I thought. It wouldn't make sense for it to be over here. I was just worried that it was, but it's not. Two methyl, three heptanone, two, three, four, five, six, seven. Two methyl, three heptanone. Okay, that one's pretty easy. 2s2. Whoa, freaky stereochemistry. 2s3r. Um, 2, 3, 4 trihydroxy butane. Oh, wait. Shit. No, wait, actually, this is the one group. This is the two group. This is the three group. Oh, fuck. So it is a wedge. Then this one, this is the one group. This is the two group. So then right, so I think they're both wedges. Two, two, four, four tetramethyl pentanone. It's like a fucking birthday party. Pentanone. Alright, 2244 tetramethyl 3 pentanone. Okay, OH, methyl, 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 methyl. Okay, that one's actually easy. I don't know why. It's all these dial, butane dial. That's pretty cool. A dial. Four methyl, three pentan. Okay, so 5 pentan, 3 pentan, 4 methyl, 2 one. Okay, that one I'm not positive about. If I just look this up on PubChem though, do I get the answer? Yeah. I don't even know why I was tripping. I don't even know why I was tripping. Butane dial. This one's easy. I feel like this is actually faster. One, two, three, four. Yeah, I just kind of drew it a little differently. 3 phenyl, 2 propanol. Okay, so we got wait, what? Oh, propanol. Okay, so two propanol. This is an O. And this is a wait. What? No, I think that's right. Yeah, it's a phenyl group. Okay, so if I were to draw it differently, I would draw it like this. Phenyl group. One, two, three, phenyl. Okay, I got it. This is going to be called 3 phenyl prop 2N Al NL. What's NL? Gotta hurry it up. Okay, 6,6 dimethyl 2,4 cyclohexadienone. Whoa. Okay, so let's draw the cyclohexene. The cyclohexane. Then 2,4, so let's just call this 1. So 2, 3, 4. Okay, we got the methyl here. 1, 2, 3, 4 methyl. 5, 6 dimethyl. Cyclohexadiene. Oh. And then puts it on, it's on the 1. Cyclohexanone. Dimethyl. diene. 1, 2, 3, 4 methyl. Okay, I want to look at the answer to this one. And one thing that I hate is I feel like the parser here is just so shitty, dude. Like, please tell me this gets it. That's what I'm saying. How does it not get it? It's like this is from a textbook and PubChem has no idea what the hell I'm talking about. But we'll just have to look at the answer. 53. Are we done? Para-nitro-acetophenone. Oh, I can do this one. So acetophenone is easy. So it goes ortho, meta, para. Ortho, meta, para. So ortho, meta, para. N, O, O. Alright, let's see if I got them right. 53. Bromoacetone. I'm just gonna have to assume I'm right, because I don't know if I'm right. Drawing it like that. Two methyl. Dude, I hate when they do it like this. Why don't they draw it better? No one's answering their homework drawing it like this. But yeah, that looks right. Yeah, it's probably right. Okay, this one. See.
So okay,
Three.
I haven't talked to you because I was someone so okay, look.
Yeah.
So about the story.
No worries about that. Already published that.
Okay, yeah. The thing is that Tikali I was about to tell you, but I was doing my own thing.
Okay.
Okay, so the thing is that I was doing it. I was interviewing people.
Right.
I was sending messages, but the thing is, I only had one source, and I couldn't really publish it. I didn't have that much resources to do. I did a little bit, but I didn't know how to do it. And the thing is, I was going to Colleen, but I was like, I'm going to do it myself. So I messaged Colleen right beforehand, and the thing is that what Miss Frida said was that there was a person that got messaged right from history.
Yes.
And she came, you know the story, right?
Yes. I mean, I already interviewed her.
So basically, she gave two sources, but she never gave me the email.
Oh.
So the thing is, I was still trying to get people, but I never got people.
Where did I get the freaking...
which was really late.
Gotcha.
And the
I
thing
don't
is,
know
I
where I
messaged
got this from.
Colin never gave me the two sources. And the thing by then, I just gave up.
That's the reason why you want the story on the way.
Yeah.
Right.
Yeah, that's why. But the big thing, I should have gave you the story first.
No. It's all good. It's all good. Yeah.
We're all good now?
Yeah.
You're not mad on me, right?
No. Fine.
It's like you had to do. Like, how did you do it? Story.
Oh, well, thanks to all the sources you compiled together. Yeah, you actually interviewed or emailed some of the backers.
Yeah.
Those are very helpful.
Did they get back to you?
I didn't follow up. I just used what they responded to you as quote. Because I feel like they're important.
Okay.
Yeah, they're important. So,
Well, you know when you do.
During the on Tuesday, 2 days before the deadline, I'm just gathering all the information. I got, and then I started to draft the stories, and then I also created a.
Alright, I'm not doing SNR.
Statistics
SNR is no good.
for those 176 courses.
It's okay. You're not mad. I feel so guilty. I feel like I regret it.
It's all good. It's all good.
It's all good.
I understand because that's your first time, right?
Yeah, it was my first time.
Yeah,
It was a big story for me.
Yeah, I know. Yeah, I think we should have assigned like the unit a little bit lighter. That's important. So
Yeah.
we're gonna
Okay, we gotta name these.
Yeah,
because I hope that you
Alright, so this is cyclohexanone. So first off, hex.
that's good.
I went
Oh.
to, I should have told
So
you,
that's
but I
1,
went to
2,
a
3,
journalism conference
3 methyl,
about migration or whatever.
Really?
cyclohex 3. Okay, so it's gonna be 3 methyl,
Have, like, women
cyclohex
and I don't remember
3N
it's been a few weeks ago.
own.
But
NO.
what I got
3
was,
NO.
was that I'm going to talk to somebody called or whatever.
Okay, so
Uh,
this one's easy. Okay, now we have C OH H CHO CH2O. Alright, so we have propanal. Wait, what the fuck is this thing? It's like a vicinal diol. So it's like 2,3 propan. I'm skipping the stereochemistry because I don't really care. 2,3 propan diol al. Yo, what is the name of this one? That one I want to know. We gotta finish these names, boy. We really gotta finish these names. Okay. This one looks fun. Oh, fuck these names. Two methyl. 1, 2, 3, 4, 5. 5 isopropyl. 2 methyl, 5 isopropyl, cyclohex, 2N own. We could also say this is 5, 2, ol. I don't know, something like that. The ability to give things names is very important. 1, 2, 3, 4. Oh wait, 1, 2, 3, 4, 5. Okay. Then we have a methyl. And then we have. So this is gonna be 2 methyl, pentan, 3 own, or 3 pentanone. Either way you want it. Okay. 1, 2, 3, 4. Butanal. It's gonna be 3. It's gonna be. I actually don't know how to name these. So it's gonna be butan. Oh, you know what it is actually? It's not. It's gonna be the other one for this one. It's gonna be 2, 3 dihydroxy propanal. But like when you use all versus hydroxy is weird. There's some rule there, but I don't know what the rule is. So this is going to be 3-hydroxy, 3-hydroxyl, is it hydroxy or hydroxyl? I don't know what the right answer. 3-hydroxy butanol. All right, last one. Oh, dial. It's a. Oh, but wait. No, but it's not a. I have no idea how to name that one. We gotta look at the answer. 3-methyl 3-cyclohexanone. Yeah, that's right. Okay. Dihydroxy, not hydroxyl. 2,3-dihydroxyl propanol. Boom. Fuck the stereochemistry. I don't care about that. Oh yeah, these need to be switched in the order. Okay. 5-isopropyl 2-methyl 2-cyclohexene. Oh. Okay, there you go. That one's like mostly right. Alright, D 2-methyl 3-pentanone, that's easy. 3-hydroxybutanol, hydroxybutanol, and then F, parabenzene di. Oh, so it doesn't actually matter if it's a cyclohexane or a benzene. All that matters is friendship. Parabenzene carbaldehyde. Alright, that one's interesting. Alright, so this one I definitely did not get. So, ring plus L is benzene carbaldehyde. But usually we just call this benzaldehyde. But anyways, we could call this 1,4-benzene dicarbaldehyde. Okay, so the only thing I really learned besides grinding this out is that it doesn't, any ring plus aldehyde gets the suffix carbaldehyde. Okay, D6. Okay. An alpha beta unsaturated ketone, C6H8. So 3, 2. Just put the carbonyl here. So 3, 2, 2, 0. And the alkene here. This is gonna be 1 and 2. So this is 7, 8, 10. We need another. Okay, I don't know. That one's interesting. An alpha diketone. I think that's just a ketone vicinal, a vicinal ketone. Or a vicinal diketone. There's so much lingo. An aromatic ketone, C9H10O. Dude, that's so dumb. I hate drawing large rings. What I find is you should just draw a circle with a slash and you put the number. Because, like, oh wait, it's actually a 9-numbered ring. Wait. Actually, there needs to be something special, because if I have... The double bonds aren't just, like, random. I don't know how you do that. That one's weird. A diene aldehyde. 3, 5, 6, 7, 8, 9, 10. So I think actually what we have to do is we have to put okay, so now we have 2, 1. One. Oh wait, so 2, 3, 4, 5, 7, 9. Wait, what? I don't know how to do these. Oh, rings, bro. That's how you do it. Rings. What section was this? It must have been in here. I'm definitely missing some of that. Okay. Wait, what? Oh, an aromatic ketone doesn't have to be. I see. 3, 7, 10. Okay. Okay, that's cool. Yeah, so the main thing is just you need rings. If you want to get rid of some hydrogens, you need to add some rings to increase the degree of unsaturation. How would you use a Grignard reaction on an aldehyde or ketone to synthesize the... Okay, so 2-pentanol. Wait, 2-pentanol. You would have to do it on... I would do... What's it called? Ethyl magnesium bromide? No, methyl magnesium bromide plus butanol. Okay, so okay, that one's easy. I think there's a lot of ways to do it. Okay, butanol. OH. Okay, so butanol. Uh, that one's kind of weird, right? Because it's one butanol. It's a primary alcohol. How do you make a primary alcohol from it? Vineyard. Oh, you gotta do formaldehyde. Bam! I'm fucking goated. Alright, so you gotta start with formaldehyde. Okay, wait, so 59. To make primary alcohol from Grignard, you need formaldehyde. Okay. Yeah, so what you're gonna do then is you're gonna add uh butyl magnesium bromide. Butyl magnesium bromide. So boom. One phenyl cyclohexanol. Wait, one phenyl cyclohexanol? What the hell is phenyl cyclohexanol? Is that what I think it is?
No, you can still that. Yeah, still that. Yeah, you can still that.
That one I have no idea how to do. Diphenylmethanol? Diphenylmethanol, I think I know. But there's like a special name for it. But it's like diphenyl ketone. But there's a special name for it. Let me just look up diphenyl ketone because I feel like that's an benzophenone. That's right. Benzo. So if I took benzophenone and then I reacted it with, oh wait, no. If I took benzaldehyde, and I reacted it with phenyl MgBr, bam, boom, so sick. So you start with benzaldehyde plus phenyl MgBr. That's what it is. Is that all of them? Okay, I just don't know C. So 59. So which one did I do? I preferred this one. Yeah, I did this one. Okay. Methanol, yeah. Oh wait, but I messed up the carbon count. This needs to be propanol, or phenyl, whatever. Magnesium bromide fat. Okay, so then you take cyclohexanone. Oh yeah, no shit. Dude, I'm dumb. That one's easy. You just start with cyclohexanol, hexanone, and do phenyl magnesium bromide. And you get this thing. Right, that one's easy. And then this one, benzaldehyde and phenylmagnesium bromide. All right. Wait, what's a ketene? Ketene. Oh, interesting. Um. Okay, 71. General problems. I wish I could just do all of these because they're actually so fun, but no time. There's no time. Okay, when 4-hydroxybutanol is treated with methanol in the presence of an acid catalyst. All right, wait, let's draw this out. Okay, 4-hydroxybutanol. 1979. Okay, so butanol, 4-hydroxybutanol. And then we have what? Methanol and acid. And tetrahydrofuran methyl 2-methoxy. 2-methoxy tetrahydrofuran is formed. Explain. So it's like an acetyl formation, but the acetyl formation is not with the same alcohol. So one is intermolecular or intramolecular, and the other one is not. So okay, here we go. So here is the so if we drew this differently. So this gets an H plus. This attacks. Wait. Hold on. Right, yeah, because it becomes five-membered ring. Okay, but then, what happens here? Yeah. This thing has a lone pair. This thing goes OH2 plus. This pops it. Then we have a double bond here. But this is a plus. So then CH3OH comes in. Wait, actually, I don't know what's happening. Oh, right. It's not going to attack this plus. Why would it attack this plus? It's going to attack this. Electrophile. Okay, that one's easy. Cyclic acetyl. That's actually really cool. All right. All right. This one's gonna be harder. Conjugation. Wait, 21. Oh, I'm fucked for these, bro. We've seen that the Diels-Alder cycloaddition reaction is a one-step pericyclic process that occurs through a cyclic transition state. Propose a mechanism. Wait, so let me just review. The standard. So we have this diene, S cis diene. Oh yeah, okay, that's what I thought. You guys piss me off, dude. Oh my god, I'm under pressure right now. All right, so here's what happens. We have this thing with like whatever, uh, bromoethene, and here's what happens. Pi dumps in, pi dumps in. Only one pi remains. And you can do it with a triple bond. And so the mechanism here is we end up with ethene. So here's what's going to happen is I think it's just that like um let's say this pi shifts over here, which pushes this into a pi, which pushes this sigma into a pi. So it's kind of a rotation around this part of it, of this face. Can we see? Can I see if that's right? Okay, so we're done with this chapter 19. Keep the book open. Okay, here we go. So 21. Wait, we gotta remember this kinetic control and thermo control. Deals out to reversible when products are much more stable. Right, the 1-4 shit and the 1-2 stuff. Okay. Dude, why'd this video go? Why'd this video? Oh man. Whoa. I've seen this before, but this one's freaky. Yeah, I have no idea what the mechanism of this. I thought it had to be open. Oh wait, here we go. Oh wait. Oh, what? Wait. This is a different product than what they're saying. Oh, so this is the mechanism by which it forms. So the dienophile just comes in. Okay. All right, it's starting to make sense. So it's gonna just come in, like, let's just say on the top. Pretend this thing isn't here. So then this thing forms. We've got a double bond. It's gonna make the sigma bond. This goes over here. This goes over here. And then this O and this O, they stay. But then what happens? The double bond in this product is not conjugated, and a more stable product can be formed by the loss of CO2. So this goes here, and this goes here. Ah, that's actually cool. Okay, I'm starting to get them. That's kind of interesting. Yeah. my checking. Dude, the goobers you see at this school, bro. It's just insane. And I'm one of them. But goddamn, there's goobers everywhere. Right there. Okay. This is the same one, right? I should draw this one. But yeah. So, oh, interesting. Actually, it's different than I thought. Okay. Step 1. Find the dying. Here's the die. So now we have this unconjugated dying. But what we can do is we can, yeah, go like this, this, and this, and we can form the conjugated dying. Or it's not even conjugated dying. It's just a like a benzene. All right, that's really nice. Okay. I'm gonna draw that one. Okay. So we have N CH3. N double, oh no, single bond. N double bond C CH3 N double bond N. Okay, then we're getting this acetylene thing. There, this phenyl phenylethyne. Okay, and here's what happens. You find the diene. You make wait. I actually don't get the arrows. This goes into here. Right, this connects to this. Okay, yes, you do end up with a double bond here. There's that tiny line that indicates that there's a double bond there. And so then the idea is you basically just, these are ends, and you just slice off ends. And the way that you do that was pretty nice. Is you take the sigma, pour it into there, and then you get N triple bond N. Okay, I actually really like this mechanism. I have no idea how you use it, but pericyclic reactions, they're pretty interesting. Dude, how many of these do we have to do? Okay. In any conjugation always just find the diene and look at whether deals alter. Okay, 40. It's useful because after the Diels-Alder reaction, it can be converted into a product that can't be accessed by a typical Diels-Alder reaction. Show the Diels-Alder adduct and propose a mechanism that accounts for the final products. Okay, step 1, find the diene. Right, so this is going to shift into sigma. This is going to shift into sigma. This is going to form the double bond, the one alkene that remains. Okay, so let's just draw that.
I'm gonna tell her, come to this address tonight at 1 a.m. She said, I will find you. What? Did she text me saying, I see you at your cousin? Wait, what?
No, parking lot. Then we had a lot of
Which one's right here? You know that
Then
number?
it goes
Yeah, which one is that? First, you
go very straight. It's straight.
no, what, I'm sorry. That's something here. So it's part of it.
Oh, you in the name of the place? I'm not sure. You know? There.
Okay.
No.
Okay.
Okay, so I got the product, the deals. I got the Diels-Alder adduct. Now we're adding HCl. And they're saying that it forms this cyclohexanone carbaldehyde ene. What the hell? Dude, what? That is a freaky ass reaction. Okay, so wait. Here we go. Okay, so I got this. So I'm right here. Now what happens? HCl, this OCH3 takes a proton. And then the core, dude, come on, man. Some of these mechanisms suck. Like this one, I hate this one. Cl minus attacks the silicon. Okay. And then we get the aldehyde. But that's not even. Oh, wait, that's kind of cool. Oh, and this pops off? That's actually crazy. So it makes methanol. Don't have time for this shit. 24. Weird. Ethoxy protonates Cl minus attacks silicon, forces carbonyl and alkene form and ene to shift to kick off the oxonium ethoxy. Okay. Okay. 31. All right, step 1, find the diene. Okay. Find the alkene. Diene, alkene. So, how does this work? Okay, is this going to be bicyclic? I have no idea. I'm not very good at these Diels-Alders. Wait, 1, 2, 3, 4. Fuck. God damn it, dude. What is going on here? This connects to this. So there's a it's a fused ring. I get it. Okay, so this isn't here. This goes like this. Okay, it's not the prettiest, but it's right, probably. Okay, this is 31. Yeah, so here we have a fused ring, but this, oh no, yeah. Okay, but that makes sense. Could be. Where we have a hexadiene, cyclohexadiene conjugated. So there's the diene. So actually I'm going to flip this around. I prefer it flipped around. Plus this cyclohexa
Thank you for coming and supporting. Thank you for coming and supporting.
Okay, so what happens? We have this dot here and this dot here. So this sigma bond will, or this pi bond will go here, this pi bond will go here, and this pi bond will go here. I need to review the cyclotropic, or the cycloaddition, electrocyclic, and sigmatropic. I think I can remember them, but I might want to check them before I do. And the naming of bicyclic things is like totally fucked. So dude, imagine trying to draw this on an exam. What the fuck is that? I know, I see that there's two mirrored bicyclic rings. Oh, connected to one. That's actually cool. That's actually pretty sick. Okay, so. Alright, so 31's not so bad. Wow, that's a massive molecule. You have this diester here and an alkene. Okay, so show the structure including stereochemistry. That's going to be important because the main thing is that, like, look, this is a trans alkene. Oh, that's actually a better way to draw it. No, but I got it. You were right. This is a dying. This is a dying. This is a dying. This is a dying. And this is a dying. But this is the only one that can actually rotate to be. I mean, actually, can't. Why can't it? I don't exactly have time to figure that out, but why can't the dying attack here? It's a little confusing. Oh boy. Okay, but I mean, we got the right answer. But it's only because I knew the answer beforehand. This is, okay, 34. How can you account for the fact that cis 1,3 pentadiene is much less reactive than trans 1,3 pentadiene and deals all the reaction? What does that even mean? This is a nice way to draw it. C, C, C. Cis.
Wait, where's our carrito? Oh, it's over there.
What are they saying? They're saying that the transdiene, the transdiene is more reactive. Even though you need. So this thing needs to spin, and this thing needs to spin. Oh, but this. Okay. Yeah. Okay. All right. Yeah, there you go. Look at that line. Oh, okay. This one seems easy. Bro, it's gonna be okay. Wait. Rank them or expected reactivity. So we expect the most electrophilic alkene to be the most reactive, right? So then it's gonna be 3. Or let's do it C. Then B. Then A. Then D. Okay. That one's easy. Unless there's a weird niche resonance that I don't see, I feel like that's 37. Okay. One 3-pentadiene is much more reactive in Diels alder than 2,4-pentadienyl. Why might this be? Okay, so Is it literally just 1,3-butadiene and then this weird tetrahydrofuran dione thing? Like, is that all it is? Because if it's not bicyclic, then this thing has to be open. Okay, let's try this. Alright, so here we have a hexagonal ring. Alright, so we must have started with a pentagonal ring. That was like this. There's our conjugated diene. No, we reacted it. Oh, okay, this one's easy. Dude, these are easy. Alright, so then this. And because there's not two, then we're good with cis-trans. This is gonna be a weird one. I don't even know how you do this one. How do you do this one? I think. Oh, what it is you're going to be use 2 molecules of the diene and 1 molecule of the dienophile. So, but this is still open. So we're still going to have like 1,3-butadiene, but 2 molecules of 1,3-butadiene to a cyclohexadiene. That's what it is. I got it. That's easy. Get the dione and then the diene. And then this, like this, like this, like this, and then like this. Alright, that's easy. Is this one easy? It looks like it should be easy. Oh, it's a methyl ester. Okay, methyl ester. Pericyclic reactions are fucking cool, man. Oh, but it's gotta be. Oh, dude. Okay, this is the good one. It's gotta be an alkyne. So it's this weird alkyne methyl ester thing. I think I got them all. So yeah, diene, dienophile. Bam, bam. Diene, dienophile, easy. Diene, diene, dienophile. Diene, dienophile. Damn, I'm cracked. I got this. Holy cow. Alright, so that's it. I'm gonna walk around for 10 minutes, then review some quiz questions, and then that's it. Maybe we'll review the homework. I don't know, but I'm done. I did it. I got through all the problems.